This is GCSE Further Maths Pure. We're in Chapter 7 Matrices, and this is 7.6 and finding the inverse of a matrix. So we think then to take down would be that the inverse of A is called A to the minus 1. You might be vaguely familiar with that sort of thing anyway. Then A to the minus 1 is going to be 1 over the determinant of A, we did that in the last video, upon D minus B minus CA. So what have we done? If it was A, B, C, D, we've changed around the A and the D, and we've changed the signs of these ones. So that's how you find the inverse then of a matrix. And the inverse of a matrix is the matrix you multiply the original matrix by to get the identity matrix. It's a bit like finding the reciprocal of something. Something times the reciprocal is going to give you 1. That's effectively what we have here. You can't divide two matrices, so if you multiply it by its inverse, that would make it work. So A upon A to the minus 1 gives you A to the minus 1 upon A, which gives you I of course being the identity matrix. So it's much more straightforward if you actually look at an example. So if A is 1, 3, 7 minus 4, find A to the minus 1. First of all, we need to find our determinant. Determinant of A is of course AD minus BC minus 4 minus 21, and that gives us then minus 25. The inverse of A is then 1 over the determinant upon D minus B minus C A. Again, I wouldn't learn it off. I would work out that you change around these two and you change the signs of these two. So that's going to be minus 1 over 25 upon minus 4. Change the sign of a 3, minus 3. Change the sign of a 7, minus 7. And I've changed these two around, so it will be 1. So that's our inverse. Sometimes people multiply this through, so that would be what then, 4 over 25 with the two minuses and stuff in there. Some people might try to tidy it up and change the minuses around as well, but that's okay. Part 2 then says to prove that this equals this equals this. So let's do that. We need to multiply these two things by each other. So first of all, we're going to multiply A. That's inverse. Sometimes a wee dot just means we're multiplying. So A is of course 1, 3, 7 minus 4, and we're multiplying that. I shouldn't have done that. I need a minus 1 over 25 on the front. Multiplied by minus 1 over 25 upon minus 4 minus 3 minus 7 1. I'm going to take the minus 1 over 25 out the front. One, 3, 7 minus 4 multiplied by minus 4 minus 3 minus 7. 1. That's minus 1 over 25. Again, we can multiply these. They're both 2 by 2s, and the result will be a 2 by 2. You get well used to that whenever you're dealing with square matrices. 1, so first row, first column, minus 4 plus minus 21. That gives me minus 25. This is in the first row, and it's a second column, so first row times the second column. Minus 3 plus 3 is 0. Second row, first column, minus 28, and then minus 4 times minus 7 is plus 28. That gives us 0. And then second row, second column, that is minus 21 minus 4 is minus 25. If we then multiply that through, we get 1, 0, 0, 1, which equals I. That's what we're hoping for. We need to check it the other way around as well, because that's what the question asks. A to the minus 1 upon A. Give us up a bit more space here. We should be okay. So A to the minus 1 multiplied by A. That is minus 1 over 25 upon minus 4 minus 3 minus 7, 1 upon 1, 3, 7 minus 4 minus 1 over 25, and then let's multiply these out, see what we get. First row, first column, so I multiply my first row times my first column. Minus 4 minus 21, so that's minus 25. That's good news. First row, second column, first row, second column, minus 12 and plus 12, so that's 0. Second row, first column, minus 7 plus 7 is 0. And then this is in the second row, in the second column, we can multiply our second row by our second column. Minus 21 minus 4 is of course then minus 25. That gives us 1, 0, 0, 1, which is of course equal to I. So we have proven it. Therefore, A upon A to the minus 1 equals A to the minus 1 upon A equals I.